Good morning. It's John Gilkison here. It's Monday, the 14th of June, 2021. And I wanted to shoot this short video on the aerodynamic loading of car carriers and cargo carriers, and versus putting them on a roof of a car versus putting them behind a car, and some other things. This ain't going to be long because I'm not going to get into specific numbers or anything, but except to show you that I've had a piece of plywood around and I cut out this template of a car carrier. Now, I looked online and I found car carriers at 19.5 inches by 39 inches. It turns out that my template is 38 inches by 20. It's only 1/2 of a square inch off. So, but it's a little taller than it should be and not quite as wide, but you're going to get the general idea. Now, as you can see, I own a 2019 Chevrolet Bolt back here with a 60 kilowatt hour battery pack. Has about 240 miles of range from the manufacturer. And you might notice I have a quilt draped over the roof line because I'm going to put this template on top of the roof. Now I don't want to scratch the paint. However, just to precede this, I'm going to tell you the car is rated to have a 25.8 square foot of frontal area, and it has a drag coefficient of 0.31 roughly. And this template of a car carrier has 5.28 square feet. So in other words, the car carrier has 20% of the frontal area of the Chevrolet Bolt. So it's a 20% increase in frontal area. Now, as soon as you put this up there, you no longer have a 0.31 drag coefficient. So whatever your coefficient of drag times area is for the car as it is stock, as soon as you put a car carrier up there, that CDA not only goes up, but the multiplier that determines the CDA, the drag coefficient, increases also. So you can expect at highway speeds you're going to see a significant reduction in your a significant increase in your drag and a reduction in your miles per kilowatt hour. So, but I don't have any hard and fast numbers for you yet. I don't own a cargo carrier. I did find a picture of a cargo carrier I had on a vehicle in 1990. That's over 30 years ago. And it was on a Toyota Tercel wagon. And even at that time, I understood it to be a bad idea, that it was having a significant impact on my MPGs. However, we put all of our camping gear in it, and at that time, and it was a storage place for all of our camping gear. We only lived in 320 square feet of house, so we didn't have much storage. And so when we went camping, we threw that up there on the roof. But still, it's not the way to do it, and I'll demonstrate the best way to do it here shortly. But first, we're going to show you this. So there's the car. Remember now, slightly less than 26 square feet of frontal area, and a coefficient of drag of 0.31. So here's a cargo carrier being put on the roof. Again, as I stated earlier, this thing's about an inch taller than it should be, and it could be about an inch wider. But you get the general idea here. This is where the airflow over the vehicle is the highest speed is over the roof. And so the impact on aerodynamics is really significant. Now, I've contrived to, I'm going to stick this over here for a minute. I've only got the camera on a tripod that's truncated, so I can carry the camera around. Now here's a different use case scenario. I put it on the back of my pickup truck. So if I had mounting points back there, I could put a cargo carrier behind the cab of my pickup truck. And literally, now imagine that thing, that's a template. Imagine that thing had length, 40, 50 inches long. The air coming over the top of the cab of the truck would just reattach on top of the cargo carrier. And it would help do something they call wake stuffing. The air comes over the top of the truck, the cab of the truck, and it does something called vortex shedding. So it curls down and curls around, like that, and around the sides and goes whoomp. And it tries to fill in that area behind the back of the cab of the truck. And if there's a physical object there, it's just going to reattach to it and continue trying to flow off. So just by carrying a cargo carrier, and I've seen people do it too, so some people have caught on to this. If you put a cargo carrier back on the bed cover of your truck, you can improve the MPGs you're getting while you're hauling this cargo. So this is a really good idea. Now another one is, let's see if we can't set this camera up. Oh, I don't have a good place for it, but let's see what we can do. Yeah, this will work. This is the back of the Chevrolet Bolt. So let's imagine that you had a tow hitch back here on the back of the boat and you had a cargo carrier. Okay? Now you take your cargo carrier, your cargo carrier, and you set it on top of you. So here it is back here. Again, what you're doing is stuffing the weight. And so the air coming off the back of the vehicle, some of that void is filled that the air is trying to move into. And so it reduces your drag also. Now, putting a cargo carrier on the back of you can put all kinds of luggage or whatever you need on a trip. And the one I'm looking at is an aluminum cargo carrier from Harbor Freight, and it can hold up to 500 pounds. The best hitches I'm seeing out there are rated for 300 pounds of tongue weight. So that would do. I'm never going to carry 500 pounds. But it could tow trailers up to 2,000 pounds in weight, which would be a good replacement for a pickup truck. I mean, you could go buy lumber, you could buy sheets of plywood, drywall, whatever, and put them in that trailer. 8-foot long trailer, a lightweight trailer that was rated to hold up to, let's say, 1,500 pounds, and then it would be a suitable replacement for a pickup truck with your electric car. But on top of that cargo carrier, you could build a light aluminum framework, and using a product called chloroplast, which looks like cardboard, but it's made out of plastic. You could build a structure, a very lightweight structure, attached to that framework on the back of your vehicle. That's something we call a boat tail. That would allow the air to come around the vehicle and begin to taper back in and reduce the wake area. Now, if you do a measurement on this vehicle, there's a wake area. There's so much rear area of the truck. That's called the wake area. And you could reduce the size of that wake area, let's say by 30% or so. It would be possible to take the drag coefficient of this car down from 0.31 to 0.22 or 0.21, which is Tesla Model S territory. And this 240-mile range vehicle on the highway would suddenly have a range of 300 miles with a 60 kilowatt hour battery pack. So in many senses of the word, it would outperform a Tesla because 300-mile range Teslas have 75 kilowatt hour battery packs. It is a slightly smaller, lighter car, I'll give it that. Now, one thing I would like to do is put some panels over the rear wheels to try to cover some of that area there. It would probably just be the upper portion because the wheels tend to stick out a bit down low, but that would be part of this boat tail structure. But all of this would be easily removable. You'd have some clips that would go hook into the right here where it fits in. They're just little hooks that go around and fit in there. They're for mounting various things. You can do bike racks, all kinds of things. And you could attach the upper portions of this boat tail to it so it would be secure and it would have a framework, and your straps would attach to that framework. And so there you are. And if you wanted to take it off, it would be a matter of a few minutes to unhook it and pull a pin and pull out the cargo carrier. Set it on the ground, and then you could use the lift gate to access your stuff in back. I'm not saying it's super convenient, but it wouldn't be so inconvenient that you couldn't do it within a few minutes. And they make what's called swing away hitches also, but they add extra weight and they cost money. They're not cheap. This is something that you could actually put on here, a swing away hitch, which would, like you'd see for tires on the back of vehicles, that you could swing the whole apparatus off to the side and then use the lift gate in a matter of seconds. So all this is possible. Mercedes-Benz has done a deployable boat tail to get the drag coefficient of one of their project cars down to 0.20. So I think this is exciting stuff. It's not trivial. It's non-trivial. And this whole idea of putting a cargo carrier on top of the roof when you have other options, which would, if it, at least just putting your cargo behind the vehicle in and of itself isn't going to impact your range or your energy consumption, and it might decrease it a little bit. But if you put the stuff on top of it, it's an aerodynamic disaster. So I'm going to leave it at that. I hope the visuals helped a little bit, and we'll be seeing you on down the road. In the future, when we get all this rigged up, we're going to try to do a long distance trip. We'll definitely do at least a 100-mile test with it to ring out some numbers. But a trip from Radiant Springs, New Mexico to Denton, Texas would be a really good test for it, or vice versa from there to here. So again, we'll see you. Everybody take care. Bye-bye.